our presenters have to say. Oh, all right, and I know Helene recognized several folks to help make this possible, but I also want to add my thanks to the Southeastern Partnership for Integrated Biomass Supply Systems, also what we know as the IBIS project, Southern Region Extension Forestry, of course, NSTE, North Carolina State University's Extension Forestry, and of course many others that add their support and cooperation in supporting this webinar series. As Helene mentioned, I am Brent Bailey, and I serve as State Activities Coordinator for the 25 by 25 Alliance, and we're a diverse grassroots national alliance of nearly 1,000 agriculture, forestry, conservation, business, and environmental organizations all working collaboratively to advance the goal of securing 25% of our nation's energy needs from renewable resources by the year 2025. Today's webinar will help you get a better understanding of life cycle analysis, what it is, how it works, and why we use it. Today's webinar will also introduce you to the Open LCA platform and the LCA Commons data entry tool developed by USDA, as well as demonstrate the capability of these tools. The term life cycle analysis or life cycle assessment is also what we call LCA. It's becoming a much more frequently used phrase in many industry sectors, including agriculture, forestry, and bioenergy. A life cycle assessment, or as I said just a second ago, an LCA, is really the systematic approach of looking at a product's complete life cycle, from raw materials to final disposal or utilization. It offers a cradle-to-grave or well-to-wheels look at product or production process while accounting for environmental attributes and/or its impacts. While LCA concepts have been around for a few decades, interest in their use and applications has ebbed and flowed with the nation's economic performance and what some may say to be a lack of standardization in LCA applications. However, with the concerns of greenhouse gas influences on climate and consumers' desire for more sustainable goods and services, the LCA has become an important tool for industry and other sectors. With that has emerged LCA best practices as well as basic principles. The LCA, as we mentioned, examines the environmental impact of a product by assessing many factors such as raw material acquisition or feedstock development, which can include planning, management, harvesting, and transportation. You could also look at processing, manufacturing, product life, and end-of-life impacts. However, data management, integrity, and interpretation is of the utmost importance, and data must reflect current processes and situations. A recent example of LCA data interpretation differences is the Environmental Working Group's recent claim that the life cycle emissions of corn ethanol are greater than those of gasoline. EWG concluded that lowering the ethanol targets under the Renewable Fuels Standard will reduce greenhouse gas emissions. However, a team of greenhouse gas experts, carbon sequestration, and ag economists challenged the scientific methodology of the EWG's claims and found that EWG used what we consider unrealistic assumptions and found errors in their data application. Lately, scientists from Argonne National Lab and the University of Illinois Chicago have applied the latest information from corn and ethanol production practices and techniques and have confirmed that the use of ethanol reduces greenhouse gas emissions. On a per gallon basis, corn ethanol reduces greenhouse gas emissions from anywhere to 19 to 48%, while cellulosic ethanol, next generation biofuels, offers an even greater benefit with a 70 to 115% reduction in greenhouse gas emissions. The higher LCA value placed on ethanol derived from this scanthus could actually make it a carbon negative biofuel. Today, LCAs are helping industries reduce costs, improve performance, achieve sustainability goals, and make more informed decisions. To help us today to further delve into the issues around life cycle analysis, its uses, and of course the applications of the open source and the data entry tools at USDA, we have three distinguished presenters and all experts in their field. First, I'll introduce you today is Dr. Jesse Daystar. and he is a leader in this area of life cycle assessments for forest biomaterials, and currently leads the Triangle Life Cycle Assessment as its president. He just completed his PhD. You may have recognized his name. We've had Jesse on here before, and now we can proudly call him Dr. Daystar. But he completed his PhD in forest biomaterials focused on the environmental impacts of second-generation biofuel. He's presented his research at many research findings at many major conferences and at the American Center for Life Cycle Assessment and Advanced Materials for Energy and Green Technology. You can see the rest of his biography and his achievements on the slide there, but at this time, without taking up further time, I'm going to turn it over to Dr. Daystar, and just as a reminder, we'll be collecting your questions in the chat box, and we'll address the questions at the end of all presentations. Appreciate your time. Look forward to a great conversation today, and I'm going to turn it over to you, Jesse.
Brent, thank you very much for the kind introduction. Helene, thanks for setting all this up today. Can everybody hear me okay?
You're good, Jesse.
Yeah, we hear you.
Great, thank you. All right. So today, as Brent and Helene had mentioned, that we're going to discuss OpenLCA, how to use it, and some features amongst with that, as well as the USDA LCA Commons tool and how that interacts. And Peter Arbuckle and Ezra Khan will be following up the introduction to OpenLCA with their discussion on the LCA Commons tool. So as Brent had mentioned, LCA is a great tool to determine the environmental impacts, or kind of understand what products infect the environment in what ways. For instance, the corn versus gasoline, how do we know which one would produce more environmental impacts? And LCA was the answer to that. And within everyday life, we often go to the grocery store, something such as this, a paper bag, plastic bag, or a canvas bag. Decisions we make every day can be, have an impact. So life cycle assessment is a tool which we can determine maybe which one may be better, for instance, canvas or paper or plastic. And there's been studies that, depending upon the assumptions, have found different results. And a lot of it comes down to questions like this, what bag is best, and how long would I have to use that perhaps canvas bag to make it better than using a paper bag or plastic bag once. And these are all questions that LCA can be a great benefit to use to answer these. And interesting, there's been studies on this. In canvas bags, you actually have to use a high number of times. I'm not going to quote the study directly, but a pretty large number of times to be better than other ones. So it's really interesting and not always intuitive to what the best environmental answer, the best decision is for the environment. So life cycle assessment is a great tool to get at this. So the IBIS project, as I mentioned already, has a goal of producing environmentally sustainable production or environmentally sustainable biofuels. And we have to determine, how we're actually doing this. Can we measure this? And what benefit is there, isn't there, or is there a better way to do it using certain processes and certain biomass types? So life cycle assessment is our tool, and a tool in general that we can answer this question. And today's webinar kind of aligns well with the three goals of the IBIS project. It's generate solutions. So a lot of our research has actually been focused on understanding biomass in the southeast and its environmental impacts and developing tools for that. And also outreach. And OpenLCA is a tool which is freely available and anybody can use. So it's a nice way to give a tool and empower people who may not be experts in the field and get people using OpenLCA and just performing LCAs on their research, products, or any kind of service. And it's obviously some education here today. I hope you can come away from this with some additional knowledge and perhaps be able to use OpenLCA, or at least find the resources needed to go further into that. So kind of what to expect today. I'm going to introduce LCA. Brent did a pretty good job of giving some of the background history of that, and that was great. I'm going to give a little bit of a how-to, but not too deep in details. And then we're going to go into the introduction to OpenLCA, and then further go into demonstrating that. You're going to see my screen, and I'm going to walk you through some demonstrations of explaining where everything is, as well as calculating some results and looking into things in a bit more detail. And then Peter and Ezra are going to talk about the LCA Commons. So as Brent mentioned earlier, life cycle assessment is a framework to determine the environmental impacts of product, services, or good. That's kind of a generic explanation, but it can be defined within 4 different processes: goal and scope, inventory analysis, and impact assessment. And you have the interpretation all throughout this process. And we're going to dive a little bit in more detail in each one of these 4 steps. So defining a goal and scope is a very important part that should be done in the beginning of a study. And it needs to state the intent, what are you trying to determine, how are you going to determine it, who's going to be the audience, and perhaps the reason for the study. Additionally, it's really important to define the functional unit. Are you looking at a gallon of gasoline, a megajoule gasoline, or perhaps ethanol? It's important to make sure you're comparing apples to apples. For instance, gasoline, if you compare a gallon of gasoline to a gallon of ethanol, they have different energy densities, and they're not really equivalent. So typically, 1 megajoule of gasoline is compared to a megajoule of ethanol. Additionally, it's important to determine or explicitly state what you're considering inside the system boundaries. So are you including production of the biomass, or are you including the burning of the fuel, or are you stopping somewhere maybe before the burning of the fuel, which is called cradle to gate? A lot of times cradle to grave is the holistic approach, but you can gain some value from looking at cradle to gate if you have similar products and the end of life is all the same. And within the scope as well, you need to determine how you're going to collect the data and perhaps what cutoffs and different things that different processes you're going to use to manage this large amount of data. Just to kind of show the importance of defining the goal and scope, it's just really interesting to show this slide where you have there's a bunch of studies here that have determined the greenhouse gas emission reductions compared to gasoline, and you have some that say that you can get a 114% reduction to one on the bottom right that indicates a 93% worse than gasoline. And a lot of this variation it can be attributed to the goal, scope, and system boundaries. Things like time frames, how long you go attributing land use change emissions to. And the one on the bottom right is a Searchinger et al. It's a very well-known paper that looked at land use change and attributed the greenhouse gas emissions only over a 20-year period. And that was a methodology that makes it obviously a lot worse than gasoline. So you can really dictate the results to an extent, but it's really important to understand and explicitly state your assumptions in this and what you're, how you're approaching this. So the next step is life cycle inventory, and that's developing flow diagrams, collecting data from your process. Perhaps you have a facility you can go measure the emissions from and the usage of chemicals and transportation distances. This type of data would go into your life cycle inventory. It will also include perhaps like how much water was used or how much CO2 came out your stack. So that's this is really where the meat of the work is within life cycle assessment. It can be very difficult to either collect data from an industry or a company, or if you're doing something that is not necessarily in practice yet, such as biofuels production from cellulose, you might have to use a process simulation, and that can take a lot of time, but the results from that are what's going to inform the LCA overall and how these products might impact the environment. Next step, after we have the chemicals we need and the emissions we have to the environment, we can determine or start to calculate how these different materials impact the environment. And so within the LCI, you might have, or life cycle inventory, you might have hundreds and hundreds of material flows and different chemicals. And impact assessment can reduce these to maybe 5 to 10 different things that you can, 10 different numbers that would indicate how this product or system impacts the environment, which can definitely help people understanding the data. There's a few different steps within the impact assessment. One of the first one is classification, and that is matching the emission with the type of impact to the environment. So on the left you have the pollutant or emission, and then the environmental effect on the right. And some pollutants or emissions affect more than one category. Another step is the characterization. Some of you might know that carbon dioxide has a potential to provide an insulating effect to the environment, and methane also does, but methane is actually a lot stronger, or it has more insulating effect than CO2. So typically what is done is the methane is transferred over to CO2 equivalents, which does a few things for us. It gives us a common unit that we can measure all greenhouse gases upon, which is convenient, and you can look at one number instead of a whole bunch of different numbers, as well as it relates how this methane compares to carbon dioxide, which is convenient. This conversion or characterization step, the 25 number, there's some controversy around that, and it can change depending upon your input assumptions of time frames, and that's interesting to note. So I've given a quick introduction to LCA. I didn't go through the weighting aspects of impact assessment. That's another step, but today we're just going to focus more on the first part there. So next we're going to get into the introduction to OpenLCA. So understanding the interactions between software and data is very important. It can be kind of tricky because there's a lot of different software types out there, and understanding how these interactions happen, it can be difficult. So the software is more like, for instance, if you're going to build a deck for your house, perhaps, the tools are like the hammer and such are the tools such as OpenLCA. And the lumber is the data, and it's very important to have quality data, meaning the lumber, whatever is, it's very important. It's got to have good quality, and it's only your model or your tools can't really make a good study without the good data. So the data is very important, and the tools as well are important for especially doing this in a timely manner. You can do LCAs in Excel to an extent, but managing all that data can be very, very tricky, and this is where LCA software shines. It has the ability to manage more data without having to make the user struggle through that as much. So here's a slide of just some of the LCA softwares in existence today: OpenLCA, Semi-Pro, Gabi, GREE, Umberto, Quantis. There's a lot of different types of software, and they all have some nice benefits and some features that other ones may not have. I've worked mostly in OpenLCA and Semi-Pro, and I've worked in Gabi a bit, and in Argonne's GREE model. Those are all really useful. The other ones are as well. But the software, if you lay that on top of that, is a whole another suite of different types of software, such as EcoEvent and the Digital Commons. There's a lot of data out there, and understanding how this all interacts and which tools can use what is important as well. We're going to get at that today. So here's just a list of what I just mentioned there in the slides, and I'm going to point out that OpenLCA is by Green Delta, and US LCI is NREL or USDA, I think, at this point, and there's still a lot of different databases that can interact with these tools. Within the OpenLCA framework, or just really a LCA software, here's a graphic that kind of describes how the tool leverages previous studies. For instance, this right here is a database full of other LCA studies that a user can use the tool to call upon that, and if you want to know what the impact of sulfuric acid is, it's already been determined, and you can pull that into your study. And the process inventory is perhaps how many kilograms of sulfuric acid you need per megajoule of fuel. So you put that data in to get an LCI, and then you can do an impact assessment using the impact methods, which are also in the tool, and then that'll give you an environmental impact on the right. So there's a couple different types of data sets there, like that have other LCA studies compiled for your use as an LCA practitioner. EcoInvent is process-based ones are EcoInvent, Gabi, the Digital Commons, the LCI, and the ELCD. There's some additional ones that are input and output LCA, which is more based on financial data, which is OpenIO and some other ones there, and the multi-regional data sets as well. There's a few things that are very important to the data compatibility, being able to work between different programs, and perhaps making sure that the boundary systems are correct for your study. Transparency is also very important, being able to track back where these numbers came from so the user doesn't have to take us for granted. And some software databases and programs are better at that, some are worse. So the transparency is very important. You can go back and maybe use part of their data and update other parts more specific to what you were doing as a practitioner within your study. Availability is another big one too. Gabi and EcoInvent both have a large list of components and chemicals and materials that you can use to create your product. And the LCA Digital Commons is doing a great job at compiling agriculture stuff based in the U.S. And that's something else to mention too. The databases on the right here, Gavi and Ecovent, it's largely based in European numbers. So oftentimes you need to update some things to make it more applicable to the United States if you're here doing your LCA, or manipulate some things. So the Digital Commons is great because it's based in the United States, and we have data which is more applicable to here. Another thing to mention is there's a lot of different formats for data. There's EcoSfold, EcoSfold 1 for SimmerPro, and EcoSfold 2, which is a newer database. Ecovent 3 is based in ILCD and CSV. So there's a lot of compatibility issues with transferring files from one program to another, and that's something that OpenLCA shines at, is sharing models and databases between different users, because you do not need a license to have the software. You just need to have rights to the data, such as Ecovent. So we can very easily share that. As well as OpenLCA can actually bring in data from a lot of different formats, pretty much all these listed right here. So it can be taking data from Gavi or SimmerPro, pretty much anything. You can actually use a great tool by Green Delta here. Green Delta, I forgot to mention earlier, is the creator of OpenLCA, and they support it and release new editions frequently. The 1.4 edition is the most recent. And they also created a tool called OpenLCA Nexus. This Nexus allows you to search, kind of like Google, for anything such as electricity or chemical, and it will search through all the common databases. This is very helpful because before this, it was really difficult to search through the different databases from one place. It took a lot of time, but now it's all listed. And if you just need one piece of data, you can actually purchase that from Green Delta, and it will be already formatted in the correct way for OpenLCA. So it's a very seamless process, and they've done a great job at bringing the availability to the user. So that's a great tool. Additionally, if you're going into using the software, some great resources online. OpenLCA.org is where you can go to find these. You can download it at the link there or from the OpenLCA website. There's also a good bit of documentation as a wiki. So you can go through there and find tutorials and different information. And there's also a forum where you can ask questions and get some pretty, usually a timely response to that if you're having issues. So today's demonstration, I'm going to give you a quick orientation to the program, talk about some of the different parts, elements of the OpenLCA program, and then also show you how to get results and how to interpret that, and discuss just a little bit how to transfer data from one file or one person to another. So with that, I'm going to switch from the PowerPoint over to sharing my screen. So when you open OpenLCA, you have a screen such as this. You have a welcome page, and you have a database over here. You actually have to connect to this. It'll look like this when you first open, so you have to activate the database. And then you'll see a little file structure over here. And this is similar to file structures on a computer, such as a Windows computer, where you have different folders. And there's several different things. So I'm going to start with just the bottom one here. Actors are people such as myself or any scientist or person using the program making data. Sources, perhaps literature. And unit groups are things such as mass, units of mass, and things like that. Flows are describing materials that are coming from one process to another, or perhaps materials that are coming from the environment, such as water, that are going into a process which might be used to make beer or another product, anything such as that. And so flows connect processes from processes as well. And a process is something that will change a flow or a material into another type of form and then another product. So if you're taking, for instance, biofuels, you're taking some biomass, maybe perhaps some forest residues, as well as some chemicals and enzymes, and changing that into a fuel. That would be a process. And this folder describes the different impact assessment methods. There's quite a few here, and the OpenLCA program allows you to choose different types depending on your goal and scope and where you are. Perhaps the CRACI is a US-based, and Eco-Indicators is a European-based impact assessment method. And you can open these and see what's in those too. A product system is the calculator, or what you would upload your processes into, and that's where you actually calculate results, and I'll show you that in a bit. But I like to think of it as like the calculator where you enter your data and it generates and crunches the numbers. And a project is something that's designed to compare more than one product system, so you can get some early results and kind of see how two things compare within the program. So let's go ahead and open up a process here. This is the EcoInvent database as well as the version 2.2. There's a newer one now, the EcoInvent 3, and OpenLCA is now capable of using that with the 1.4 edition, which you can see up here. So let's get into a process here. Since this is IVA's project, we're pretty interested in biomass and energy. So I'm going to pull up some biomass data here. We have, quite a lot, just to kind of demonstrate you the extensiveness of this database. It's got heat, biogas, electricity, all from biomass and cogeneration. Fuels. We've done some LCA studies on biofuels, but so has the EcoInvent, and there's quite a few here. You have palm fruit bunches, and I was looking at sweet sorghum earlier, and I might pull it up right here. So if you double click on one of these records here, the process, you get another window come up in your navigation area, and this is kind of what it looks like as you come into it. So you have a name in the top, then you have some description about it, perhaps how much it is, where it's produced, how it was produced, and then the documentation, and that's very important, as well as the location as you have down here, some sources, and that's really great. So it's kind of the background to the mini or the LCA that was done before it was entered into this. And within the Inputs and Outputs tab at the bottom here, you can see the different materials that went into making this biofuel. The ones that have the gears are ones that come from other processes. And the ones that have this little stick figure with little balls on the ends, which is represented like an atom or a molecule, is something that comes from the environment. It's like a resource in air, and there's different types of categories of flows here. And remember, flows connect processes, so there's a disposal process that a flow is coming out of and into this process. And you can list the units, flow property, and also the amount. And with the EcoInvent database, there's also uncertainty, and there's data surrounding that, which allows you to do a Monte Carlo uncertainty analysis in this program as well, which gives you better data which allows you to more understand the probability of a product being better than another, or maybe how certain you are within a certain range of your results. And at the bottom here we have outputs, and there's one output at the bottom, or one output that is designated as the particular product of interest here, and it's a sweet sorghum, and that's what everything is more or less measured by. And there's also a lot of other products sometimes that come out of this. There's a few other tabs here, for instance, the administrative and modeling validation and parameters. The parameters are interesting. You can, it's a higher level feature within OpenLCA. It gives you the ability to make some very flexible models that can be changed very quickly altogether. So if we want to understand or determine or calculate the environmental impacts of this, we can create a product system by clicking this button right here. So I'm going to click that button, which I just did. It's selected already the material there, and then I'm going to hit Finish. It'll take a few moments to create to compile all the different processes together. This used to take much longer in the 1.3.4 OpenLCA version. The 1.4 has increased the performance quite a lot, which is a great benefit from a usability standpoint. So here, this is called a product system, and if you remember, I showed you where that is located before, and that's up here, product systems. So here we have in distillery, and that's the one we were just looking at. And we're looking at kilograms and the target amount, and we can calculate from here the environmental impact. But before we do that, I always like to look at the model graph, and that makes sure that you can see where everything is connected up. So here we have sweet sorghum in distillery, and we have all these different processes or materials that it took to make that material or the distillery. And you can see there's quite a few here. So ethanol fermentation that blows up into quite a few, and you can go to diesel burn, and it gets quite complicated. So as you might imagine, there's hundreds and hundreds of connections here, oftentimes circling back onto themselves with different processes. So it's a lot of data and a lot of stuff to track, and that's why LCA software really shines, whereas doing things Excel would be much more difficult. So once you've made sure everything is connected up, you can hit the Calculate button. And I'm going to do an analysis now, but we have the option of Regional LCA IA, which is the Regional Life Cycle Impact Assessment. That's a new feature that's experimental and very unique to OpenLCA. There's also the Monte Carlo simulation, which will give you an idea of your uncertainty. So if you're going to calculate your results here, I'm going to pick the Tracy Impact Assessment method here, and it doesn't have any weighting, so I'm going to hit Calculate. It's going to take just a few moments, and again, this is much quicker than the older versions.
While that's loading, Jesse, this question is pretty relevant here. Does the LCA software help to select the most cost-effective alternatives? Is there that capability?
Cost-effective from which standpoint? There's something called total. There's some things in here that can approach that, but from a processing standpoint, usually it's not enough alone, but it could be a tool used to help inform that sort of analysis.
Okay. Thank you.
So when you calculate the product system here, you end up on a screen such as this, and you have flow contributions at first, and you can track different flows through the system. I typically like to look at the environmental contributions, so it breaks it down to different impact categories, such as global warming impact, and you can see that where the emissions or the impact actually came from. But there's actually some other tabs on here that give you a better view of that. Before we're getting to that, we can go to this other tab, which is Inventory Results, and this will list all the inputs from the environment that it took. It's quite a few, as you can tell, and all the emissions to the environment. Each one of those will have an impact. And that's the life cycle inventory.
Just to make sure we're clear here, so what we're actually doing right now with the sweet sorghum is to see the environmental impact if we were to produce fuel at a refinery. Is that what we're looking at right now?
Yes.
Okay.
And I'll be clear, yeah, this would be something along the lines of a cradle to gate, meaning we're not burning the fuel yet. So this is just the production of the fuel. And this is more of a demonstration purpose, but it is really interesting to look at the whole cradle to grave.
Yeah, it's definitely very detailed. So I was getting lost there, so I guess we're just kind of looking at, you said cradle to gate, if we're going to use sweet sorghum as a feedstock in the distillery to make fuel.
Yes.
Okay, great.
Yes, thank you, Helene, for kind of putting it into context there. Yeah, so the inventory is quite large, but maybe we want to look at fewer impacts, and here we have the results broken down to global warming and acidification and a few others here, so it's much easier to look at. Another thing that LCA is really great at is understanding or helping find where the big players are or what's important to the, what's driving the environmental performance. So here a contribution tree can be a very useful tool where if you look at this, it shows you the different processes. I might have to scoot this over. But you can see the sorghum is where it's 43% of the impact comes from, and you can just dive down into understanding diammonium phosphate is a pretty large player there, and which parts of the process actually contribute the most. So that's a nice feature to really figure out what components of your process, where are the emissions coming from, and maybe where should you focus to decrease these emissions. So that's a kind of a rundown of what you can see. There's some other really neat analysis tools that you can look at. But if you want to compare gas versus ethanol, you could use a project which will look something along these lines. And I've already made one here for time's sake. And let's see here. Maybe that's not working. You can add two different variants here. I'll do this one right here and another one, gasoline. And this is totally fictitious. We need to make sure we're comparing the correct things in the right way. But just to show you how the feature works, you can hit calculate, and it'll run in the background. It'll run for a moment and give you some results.
I guess while that's running, take another question here. So does it do cost and benefit analysis the software?
Cost and benefit analysis in terms of the environment, yeah, it does have a feature which addresses some of that. If you're just looking to understand the profitability of your supply chain, or some things like that, maybe not as much, but yeah, it has some abilities. We can talk about that perhaps after.
Right.
So here's some results. You can see that the red, which I think was gasoline, has a higher impact or higher flow of that feature. But if you're looking, yeah, we're just actually set flows here. I didn't select a process, didn't select a impact assessment method, so we just look at flows. So if you were to do that, you would select one of these impact methods. But in efforts to give Peter and Ezra some time to talk about their project, I'm going to move along here and just mention how to get this data from your program into Excel, because I know a lot of us work in Excel and we need to have this data. So you can actually click this Export to Excel, and I'll take all these different tabs and put it in Excel, allowing you to manipulate it further and make your own graphs for publication, which is very convenient. So it's really easy to get the data out of Excel. And perhaps you want to share some custom models you made with a colleague for review, or just whatever your purpose is. There's a lot of ways you can do that, and you can do that by clicking File and Export, and you can export processes, impact methods, equals bold. There's a lot of different file formats which you can export, and that's going to be part of something that's important to the LCA Commons, which Peter and Ezra will talk about next. Okay, so I've more or less given you a quick run through the program here, and just kind of give you a few last things to remember. OpenLCA is a robust LCA tool. It's very comparable to any other ones out there. It's free and open source, so you don't have to pay yearly subscriptions or a large licensing fee such as others. However, you do have to pay for data unless it's free data such as LCA Commons. And it also enables a higher level of collaboration with increased model sharing, because you can very easily share. You don't have to have multiple licenses of the software. And it's compatible with most data sets, and the OpenLCA Nexus is great. And it's also used by USDA to upload LCA Commons data. And if you're interested in training, please contact me. We can set something up, or have a online training or in person, and we can help you through the process of getting used to the program. With that, I'd like to thank you and turn the reins over to Peter Arbuckle.
Hey, Jesse, thanks a lot. This is Brent Bailey here. I appreciate your detailed overview of the LCA activity and the work you're doing. A lot of good tools and features there, and while there is definitely some complexity to it all, I think becoming more familiar with the tool that you have there can certainly help open some doors and create some efficiencies in analyzing processes. But I want to go ahead now and introduce Mr. Peter Arbuckle and Dr. Ezra Kahn. They'll be joining us up from USDA's National National Agricultural Library. And they'll be joining us to discuss the role of USDA in developing the strong LCA platforms. Mr. Arbuckle works on the LCA Commons project at USDA National Agricultural Library. The LCA Commons is an initiative to gather and disseminate life cycle data that represent United States agriculture. Prior to joining the National Agricultural Library, he worked for USDA's NIFA, incorporating life cycle thinking into USDA extramural research grant program for bioenergy and bioproducts. And also joining Mr. Arbuckle will be Dr. Ezra Kahn, who received his PhD in mechanical engineering from the University of Washington with a focus on modeling uncertainty and life cycle assessment. Since then, he serves as a technical information specialist at the Knowledge Services Division at USDA National Ag Library, where his primary responsibilities has been the USDA LCA Commons. Peter, Ezra, thank you for joining us today, and look forward to your comments.
Thank you, Brent, and thanks everybody for the opportunity to present here today. Helene suggested that there might be a few people out there who don't know what the National Agricultural Library is, and while I'm shocked that that might be the case, I'll go through and I'll start with an introduction to the library. We are located in Beltsville, Maryland. We're co-located with the Agricultural Research Service Beltsville Research Area, and we're organized under the Agricultural Research Service. We were established in 1862 to acquire and diffuse useful information on subjects connected with agriculture and rural development. And recently, a little over a year ago, the library established a Knowledge Services Division. Ezra and I were the first two hires in the Knowledge Services Division. And the mission of this division is to acquire, preserve, and describe scientific data sets and transform and develop visualization tools, transform data and create data visualization tools where applicable. The NAL is a really great platform for these activities in the federal government because it's really closely aligned with our mission, that is the data management and data archiving and warehousing activities. Database and related software projects that occur in federal laboratories often fail in the long term because funding inevitably shifts, and when funding shifts, things that are a little bit outside your mission tend to be cut before other things. And so it's really nice that our mission, this project is in collecting life cycle data related to agriculture, or when I say agriculture, I mean agricultural products. It really falls nicely within our mission, and we feel very, very comfortable that this will persist now and into the future. Let's see, next slide. Okay. I'll now describe the concept a little bit. The LCA Commons exists to enable collaboration and data sharing within the LCA community, but also the agricultural product and even the forest product community that are doing work for LCA. As Jesse said in his presentation, the life cycle inventory portion of a life cycle assessment is really the labor-intensive part of the work in gathering all of the data that you need. And our mission then is to have a place, is to improve the information related to agricultural or also forest-based products in an effort to support people doing life cycle assessments. You can imagine the bioenergy commons, or I'm sorry, the LCA Commons as a kind of a data-centered community of practice. It's by no means, I know that term community of practice means something explicit in related to extension, but we're really focused on creating a place where people can share, can upload and download and share information and data. We're not simply we're not limiting ourselves to data, but we're also developing tools that can help the community translate and transform data, really to facilitate data interoperability. And this is a really core idea for us, and this is why we use OpenLCA in our application. And I'll describe more about that. Next slide. How do I? There we go. Oh no. One more up. You're not saying anything. Okay, no, one more. Okay, thank you. Sorry about that. So as I said, it is our mission to disseminate data that represent U.S. production for the use in life cycle modeling for farm operations, policy, and commerce. And you'll see that I focus more on farm now than I do forest operations. One, because those are the data that we have developed thus far, and two, is we collaborate closely with the National Renewable Energy Laboratory that runs the USLCI database, and the forest operations folks, Quorum, they've done a ton of great work in life cycle assessment for forest operations and forest-based bioenergy that and they use the USLCI database to host their data. And so the idea is, as Brent described earlier, the Environmental Working Group came out with a study, or you've probably heard of, there's various initiatives in Europe to to incorporate environmental attributes into trade considerations. Our mission is to make sure that when policymakers or groups informing policy or international trade organizations are doing life cycle assessment, it's our mission to make sure that the information they're using to represent the United States production is solid. And so our database is a collection of unit processes that represent United States production. And a unit process is the smallest portion of the production system for which original data are collected when performing a life cycle assessment. You can envision this perhaps in a timber system or a lumber system as, say, the sawing a tree, hauling a tree, and processing a tree could be 3 unit processes, for example. And we've begun with commodity crops, but we continue to add data from other segments of agriculture, including animal agriculture, specialty crops, and also bioenergy. We are anticipating from the NIFA grants that have the NIFA bioenergy grants awarded over the last few years, we're anticipating that much of this bioenergy data will be, life cycle information will be submitted. We've just recently, 2 weeks ago in fact, released a submission application that will enable folks to submit data to the LCA Commons. And we started working with one of the NIFA CAP grants, bioenergy CAP grants, was from the University of Washington, and we've already started working with them to submit some of their life cycle information. And we are happy to work with anybody who's interested in submitting data. And with that, our website is www.lcacommons.gov. And I'm going to do a quick demonstration of this of our website and just show you the way our data exists, how it relates to OpenLCA, and then show you the submission, a little bit about the submission application. Can everybody see
Yes, you're good to go.
My screen? Okay, thanks, William. So this is our home page, and our home page, we're getting ready to actually overhaul our home page, but the home page will be, like every other home page, an opportunity to create a community around life cycle information. We're going to revise it to include things like updates when data are submitted, to provide updates on the website, but also send messages to our listserv. And this is where you enter the database. And as you can see, the database right now we have a number of unit processes, 536 unit processes associated with agriculture, forestry, and fishing. Right now it's just agriculture, but we've categorized our data with ISIC codes, which are consistent with NAICS codes, and basically any type of data that falls within an ISIC or NAICS categorization can be submitted to the Commons. To download data and to submit data, you must sign in or register if you haven't already. The only thing we ask for when you register is your email address. You go in and you enter your email address, which is your new username, and you create a password for yourself. And you log in, and logging in gives you the opportunity to download. And as you can see, if you want to, say, look at a unit process for, this is corn grain in the year 2000 in Nebraska, you can see, if you remember from Jesse's presentation, that our metadata tabs are directly represented or similar to OpenLCA. This is what we have done is we have created an instance of OpenLCA, and we're using the OpenLCA data store as our database, and the LCA Commons is right now just a projection of the OpenLCA data store onto the web. And I'll tell you a few reasons why we did that. And so you can see that we're heavily focused here on metadata, and in releasing life cycle data on the web, it's when people submit data to us, it's not for us to say whether the data are right or wrong, but it's to judge whether the metadata describe exactly what are in the data. And you can see here that here are the technosphere flows, and this model directly reflects what Jesse demonstrated. So you can return to the results list. You can add unit processes to your cart, and then go to the download the cart. And you'll see those unit processes are then in your cart, and you can download in multiple formats. Right now we just have the EcoSpold and the ILCD formats, which are the major formats. But as Jesse said, OpenLCA has added some nice features recently in the 1.4 release, EcoSpold version 2 and an Excel download capability. And so if you're interested in downloading data, you select which format, you download the data, and you receive an email with instructions you'll receive an email where you download the data through the email. Alternatively, to submit data, you select the Submit Data tab, and it goes to our submissions portal where we've developed a number of guidance documents that we call data requirements, data formatting and nomenclature guidelines, metadata guidelines, and a description of our peer review process. All of the data submitted to the Commons will be peer reviewed by one to three subject matter experts. Again, the idea is not so much that they're judging the results of what's submitted in the unit process, but simply that the metadata submitted created a clear picture for the user of how the data can or should be used. And it's up to the user to decide what data are appropriate for their study. I'll show you the formatting and data guidelines. One of the reasons we use OpenLCA, we ask people to, regardless of what software or format they've used to develop their life cycle assessment, in submitting unit processes to the Commons, we ask them to import it into OpenLCA because that's the framework that the Commons is based on. They imported it into OpenLCA and edit it in OpenLCA and then export it in the ILCD format. It will prove to ingest into the Commons more smoothly than if it were submitted in, say, EcoSpold or another format. And so right now we're just accepting EcoSpold and ILCD, but we strongly encourage people to submit data in ILCD. And here there's some information on how to structure the names of the flows and units and categories of the data, so that one, it ingests smoothly, but two, our major objective is that data are interoperable. And so when somebody submits data to us, we want people to be able to download it and use it effectively with the data that exists in the public. Jesse, for example, EcoInvent, as Jesse described earlier.
Just kind of clarifying question. So EcoSpold is a format. Is that a software or format that works in a software? I'm just a little lost on EcoSpold.
So hi, this is Ezra at the library. EcoSpold and ILCD, these are XML formats. So they are not software specific. Because they're XML, they sort of stand on their own. But they are associated with particular software packages in a sort of an ad hoc fashion. So Schema Pro is associated with so Schema Pro distributes EcoInvent. When you buy the software, you're also buying a license for EcoInvent, and EcoSpold is the EcoInvent version of the format, their version of LCA format. Gabby is another example of a software tool, and they use a different format, ILCD, as their native file format. But technically, the formats themselves are not, they don't have to be software specific, and they've been designed to be interchangeable in this using XML. And OpenLCA you can read both,
great. Thank
both
you.
types.
And lastly, so this is our, hold on. Oh no, logged in as an editor. Yes, so I apologize. We have a little glitch. Our programmer changed my status in the database a couple hours ago, and I'm now so when I log in with my name, I'm an editor. But as a submitter, as a submitter, when you log in and you submit, you'll see a tab at the top called Submit Data, and we have a very brief form that asks a handful of questions and allows you to upload your XML files and provide us with suggested reviewers and comments. And with that, I know we're running short on time. To wrap it up, the OpenLCA, to tie it back to Jesse's presentation with this, our application of OpenLCA is we're not providing any analytical capabilities with OpenLCA, but we're using the capabilities of OpenLCA because it has tools that foster data exchange and interoperability. And this is what we're hoping, this is the platform that we're using to help the community share data. With that, I'll leave it for Brent if there's any questions or you want to.
Thank you, gentlemen, and I appreciate everyone participating and the information you shared. I know a lot of good questions have been popping up on the in the chat box there. Given the time we have, Helene, I'll just go ahead and turn on to you, and I think you've been collecting the most pertinent questions in the time we have, and hopefully we can cover them all. And I'm going to let you go forth now and offer them to the fellows there.
Sure. Thank you, Brent. And thank you, Peter, Ezra, and Jesse. What a great presentation. I've learned a lot. I'm ready to go tackle it and dive in and see those models because it's very interesting. Just not even having an LCA background, I find it very intriguing. Some of the questions I have, I guess, are more for, I guess, a different type of model. Like, I know the cost-benefit analysis model is mentioned, and also return on investment models. So I guess Jesse and Peter and Ezra, if you want to chime in, I guess how capable is the OpenLCA in doing some other kind of analysis, maybe business model analysis?
I'll chime in initially, and maybe Peter could follow up. LCA, or OpenLCA, is not really designed to do a financial analysis. I've used it in conjunction with my own financial analysis, which I usually perform in Excel, because they oftentimes require a lot of similar data, such as how much chemical is needed and other aspects. So they work really well together, but OpenLCA will not do a financial analysis such as calculate return on investment, net present value, or IRR. It doesn't, it's not capable of doing that. And I hope that answers the question. Does Peter or anybody else want to chime in on that?
Yeah, that was a good answer. OpenLCA, I mean, it does have a new capability in terms of characterizing life cycle costs that I'm actually not very familiar with, but yeah, you're right. It doesn't do cost-benefit analysis or any type of financial analysis like you were saying.
Okay, great. Thank you. The other question is, who is your University of Arkansas contact that you're working with? And this is for Peter and Ezra.
We work with Dr. Greg Thoma and Dr. Marty Matlock.
And then I guess if maybe someone from the webinar wanted to follow up with you, they can just email you. Is that okay? Okay, great.
Yeah,
the other question I have is, Are you working or familiar with the Washington, or for the Washington CAP project? Do you have connections with the Louisiana State University? And I do not know what the acronym is, but it's SUBI CAP project.
The LSU CAP? No, not directly. No, we haven't been talking to anybody on the LSU CAP, but we'd be happy to. I mean,
okay, great. Another question is, while we still have a little bit of time here, who is working on the forestry data for the? I'm not sure; it doesn't really specify, but I'm guessing maybe for the Commons.
Yeah, well, so I always forget this acronym, but Quorum, C-O-R-R-I-M. I'm sure you got a lot of folks on the phone know what that means, but Quorum's been doing LCA for years, and they do really good work. And they submit their data to the US LCA database. Can somebody help me out with the Quorum acronym?
Yes, it's the Consortium for Research on Renewable and Industrial Materials, and a lot of my master's work was actually was actually funded by Quorum, and I think some of that data may have made it into the US LCA database.
Great, thanks.
Oops, sorry, I was trying to share the Quorum with everyone. One last question we have here is the formats that are available for the LCA Commons. Could you repeat those, please?
So we would like to. They're available for download right now. You can download data in format called ILCD and another format called EcoSpold version 1, and we're working on implementing an Excel and EcoSpold version 2 download. In terms of uploading data, we prefer data in ILCD format because ILCD format captures the depth of metadata that we'd like to collect.
Okay, great. And I do want to mention to everyone that this presentation is being recorded, so you could always go back whenever you need to in the archived bioenergy webinar portal and view this session. And also, I will be posting the presentation in a PDF format on the homepage where you joined this afternoon. And questions keep coming, and we were allotted an hour and 15 minutes, so I'm going to keep plugging away at the questions. One of them is, you mentioned that training online/individual is available. What is the cost associated with that?
Hi, yeah. So the training comes in several different options, depending upon what you're trying to do, just to get introduced, help set up, or if you're trying to have a one-on-one session or maybe a group session. So it all depends on what we're trying to accomplish, and perhaps if you're academic, typically there's some reduced rate for that. So if you'd like to learn more, please just email me and we'll work something out with you. And if you have any more questions, I'll let you know. I'll answer those too.
Okay, great. And Jesse, if people just have a question on maybe something like, what does this flow process mean, or something basic, they can feel free to email you as well.
Yes, I'll entertain more questions if something basic. Yeah, I'll certainly help you through a few things, or at least point you in the right direction. There's a lot of resources online that give a great explanation, but I can help connect you with what you need to know.
Great, thank you. Don't see any more questions, but please note that they're all the presenters are willing to take any questions you have. Please email them. Also, you can email me too if you have any questions as well. I just put up the Quorum site if anyone's interested in that, if they want to use that link there. I'm going to go ahead and close the session, and I want to thank everyone for participating. This is a very informative webinar. I've learned so much on this webinar. It's unbelievable. There's so much data out there, and this free open source software is just amazing. I mean, it just cuts so much time in half, especially if you're looking for environmental impact assessments or for the life cycle assessments. Excuse me. Again, thank you, Brent, for hosting. Thank you, Jesse, Peter, and Ezra. As I mentioned earlier, recording will be offered on the forestry-webinars.net webinars page. If you haven't subscribed already, please join our email subscription list if you wanted to find out about upcoming webinars in this series. The series is focused on advanced biofuels, particularly in the southeastern United States. So with that, Brent, I'm going to pass it on to you for any additional closing remarks.
I think you captured it all, and I appreciate everybody's time. Peter, Ezra, Jesse, great job, and hope everybody will join us in the future for our next installment of our webinar series from the transitioning from the bucket to the barrel. And Helene, I'm not sure if we have a date set yet for our next one, but I know we're looking at sometime middle to late November.
Yes, and there's also been some talk of a follow-up to this LCA Commons software, or Open LCA software and LCA Commons as well. So stay tuned. I'll try to post that on the website as soon as possible. And yes, we are looking at a biomass supply chain webinar for November. And if we're unable to air that in November, then we're definitely looking at December.
Okay.
Stay tuned. And, yeah. Thank you so
much.
much.
Have a great afternoon. Appreciate it.
Yeah, if everybody just be patient with me, I'm going to put the link in for the continuing education credits into the chat window. And I'm also going to push it out. And like I mentioned, there seem to have been some problems earlier on the earlier webinar today. And please email me if you have any problems with your CEUs, and we'll get those problems resolved. There's my email, and I'm going to push it out. So thank you, everyone.